Hello everyone and welcome. In the last video, we looked at missing data. We explored different reasons why missing data is generated and what some ways are to detect and resolve them. In this video, we will move forward with our analysis of the electricity demand prediction dataset and see if our dataset has missing values. If it does, we will see how to resolve it. So let's begin. To start with, let's see if our data has missing values. For this, we will use the Pandas library's describe function. We will run it on the train and test feature data frames as well as on the train and test label data frames that we created in the last playtime video on outlier detection. As we run these four cells, you will notice that the count value for the train label data frame is smaller than the count value for the train feature data frame, indicating that the train label data frame has some missing values. Cool, not a problem. Let's now see how we can impute these missing values. Since the missing values are in a continuous value column, we can use the scikit-learn library's knn imputer function to fill up or impute these values. This function, as we discussed in the previous video, looks at the data points most similar to the data point with the missing value and uses them to fill up the value. Some things to note with this function are that this function only works with continuous values and only on data frames. And so depending upon where your missing values are, you will need to create slightly different codes to process missing values for features data frames and for label data frames that are in reality just a series or a data frame with a single column. In this next cell, we have implemented both the versions. Let's go through the label data frame first. We start by initializing the knn imputer and passing it a value for the n neighbors, which is the number of neighbors to consider when imputing the value. This number depends upon the complexity of your dataset, but values between 5 and 20 usually work well for most cases from our experience. Feel free to explore and try different values depending upon your use case. Coming back, once the initialization is done, we pass it the fit transform function along with our series data. Again, since the label data is series data and the function only accepts data frames, we use the reshape function on the data values to convert it. And finally, we use the output of this transformation to again create a series in a style that it was in before. Let's now see how the code looks like for data frames. Here, we start by splitting the feature data frame into two parts, one that only contains continuous value columns and one that contain all other columns. We then run the continuous value column data frame through the imputer, setting the n neighbors value again to 5. Once this is done, we pass it the fit transform function and convert the output into a style it was in before. Finally, we join this data frame with the data frame that had non-continuous value columns using the concat function to get the final data frame. And that is it. Once you run this cell, you will see that the count in the train label series data is now same as the count in the train feature data frame. And that is all for this video. Hope you had fun. In the next video, we will look at class imbalance rectification, an extremely important data pre-processing step performed when doing classification. See you there!